Okay, let's do a quick review of combinations and permutations. If I have 52 cards and I want to pick out 4 of them, I will have 52 choices my first time, 51 choices the next, 50 choices after that, and 49 at the end. So all of the different ways that I can get 4 cards out would be written as 52 factorial divided by 48 factorial. Okay, the reason why we divide by 48 is because we don't want all of the numbers coming afterwards. So if all of these numbers together is 52 factorial, and we want to get rid of all of the numbers out here, we want to get rid of 48 factorial, then writing them as a fraction accomplishes that, because essentially we end up with a picture that looks like this. And the factors on the top and the bottom cancel out. So we end up with just the chunk that we wanted, 52, 51, 50, and 49. Okay, so that tells us how many different ways that we can draw 4 cards. Now, that is a permutation. Okay, when we do it that way. When we do the formula n over n minus r factorial, we are finding the permutations that we can create. So permutation just means all of the different different ways that we can pull 4 cards out. Now, let's say that we got a ace, a 2, a king, and a 4. Okay, those were the 4 cards I pulled. But let's say I didn't want to count that different than somebody who pulls this out. Somebody who pulled a 4, a king, a 2, and an ace. Now, they didn't pull them in the same order, but they pulled the same 4 cards. So if we want to say that, if we want to say that those two are equivalent, then we're dealing with combinations. Okay, this is a different word than permutations. So combinations would be a smaller group. Combinations will be that original number, but you'll need to get rid of all of the permutations which are equivalent combinations. The way we do that is we divide by the number of things we're picking from. So for example, if we were picking from 4 cards and they were going to be from those ones that I gave, an ace, a 2, a king, a 4, well, you have 4 different choices for your first card. After you pick one of those cards, you have 3 different choices, then 2 different choices, then you're stuck with the last card. So the amount of equivalent hands is 4 factorial. That's why we need to divide by that number to get just the combinations. Now, if we take our numbers from the problem and we say that we want to choose 3 objects out of 10, and we want to know how many unique combinations can we get, we'll have 10 things to choose from. We only want to make 3 choices, so we need to divide by 7 factorial, which is n minus r. And if we don't want all of the different permutations of 3 objects being picked, we'll need to divide by 3 factorial as well. On the other one, if we want to have 12 objects, we want to pick 3 of them, but we don't care what order they come in. We're going to count them all of those permutations. Then we'll have this. Over here, what's going to cancel out is everything after the 8. On the bottom, the 3 factorial remains. Over here, we're going to cancel out everything after the 10, because we are going to have 12 minus 3, or 9 factorial being divided from the bottom. Okay, so 12 times 11 times 10 is going to be equal to 12 times 10 is 120. Times 11 should be 1,320. Up here on top, I'm going to simplify what I'm seeing to 10 times 3 times 4. In which case I have 10 times 12, or 120.